MT-FIMMPROP is a brand new design environment from Photon Design. It is an optional module for the flagship FIMWave software, and it allows for the simulation of the entire PIC, the photonic integrated circuit, using EME methods, eigenmode expansion methods, which until now has been limited to just a single device. And we'll demonstrate that in this simple example here of a long arm Mach-Zehnder Interferometer, which also has MMIs in the coupling regions. First thing to notice in this example here is the scale. So on the top here we're going up to 600 microns, and on the scale here down to about 100 microns. So a reasonably large simulation area. Certainly one that, if this was a 3D simulation, would take a lot of computer power for FDTD to solve, and until now would be impossible with EME, and in addition also impossible with beam propagation methods. So what we have in front of us here is a series of waveguides that have been connected together, and on top of all of the waveguide areas are these computational regions, which have been defined by the user setting up this model. It's in these computational regions that the EME method will solve the modes and propagate the modes through the waveguides and calculate the coupling between the regions. For the bend sections, EME automatically calculates the bend modes, and that's true for constant radius bends, Euler bends, or S bends, etc. And then you'll see on the left side and the right side here are the ports. So port 1, 2, 3, and 4. So we have input ports and output ports. And we'll be able to calculate the transmission from one to the other. So to do the simulation, I'll click the FIMMPROP engine button, and I'll calculate the scattering matrix. But before we do that, it's here that we control the global settings for calculating the modes. We have the choice of mode solvers, including an FEM solver and a film mode matching solver and effective index solver. The number of modes we want to calculate, which can be overridden on an individual basis if we need to. And then of course there's the wavelength we're solving at. This is a frequency domain solver, and I'm using a variable which I've defined in a variables node for lambda. In this particular case, the wavelength is 1.5524 microns. So once we've set all that, we can click the scattering matrix button, and the calculation is proceeding. The progress bar on the bottom left gives you an indication of how long there is to go. So it's going to take a few seconds, maybe in total 20, 30 seconds to calculate this large long arm Mach-Zehnder. And when we're done, we get this scattering matrix report. And the first thing we want to do is make sure we're looking at the right ports. So from port 1 to port 3, we have 90% coupling. And to port 4, barely anything at all. So we have a very good coupling to port 3 at this wavelength. MT-FIMMPROP comes with a scanner device that allows us to scan the device we just looked at, scan this variable, lambda, the wavelength, between these values of our choosing and the number of data points of our choosing. So that allows us to understand the response of this MZI. So I already did this scan, and I can bring up the data results, save us having to wait again. So I loaded in the previous results. I'll just enlarge it. So you can see here we've scanned in this range 64 data points. So we're at a resolution of less than a nanometer, and that's one of the advantages of using a frequency domain solver like EME. is that we have total control over the resolution of the data we need. So for any sort of highly resonant structures or very wavelength sensitive structures, we can control the resolution, whereas with FDTD, for those of you who are experienced using FDTD, more resolution in the frequency domain requires a longer calculation time. So it can sometimes be difficult to achieve the resolution you need. So the simulation we just performed was around about here. So let's move over to here and see the transmission in the other port. So that's going to be 1.538, let's say. So I'll change the variable, 1.538. And then I just update the scattering matrix of this device. Again, it's doing the calculation again, so it's going to take another 30 seconds or so. And then we should see pretty much the opposite of what we saw previously. Previously we had 90% power in port 3 and 0 in 4, and let's swap it around, and hopefully we see a high transmission into port 4 at this wavelength. So port 1 to port 3, that was 90%, now it's practically 0. Port 1 to port 4, 93%. So at those two wavelengths we get the opposite transmission. We also have the ability to plot the field. It takes a few more seconds to do so, but we can do that. And here we see the result. And if you look closely, we're inputting the light in port 1, the upper port. And we see here, most of the power, as we saw, 93%, is coupled into the port 4, the lower port on the right-hand side. So once we've done the design work, we have the ability to export to GDS2 file using just the toolbar button for easy mask manufacture. So not only does MT-FIMMPROP bring EME to the simulation of whole photonic integrated circuits, but it also combines the roles of both simulation and layout tools for convenience.